Welcome back. This is 7.1, the fundamental counting principle. So our objectives for this are using the fundamental counting principle to determine the number of possible outcomes in a given situation. So the fundamental counting principle, if you can choose one item from a group of m items and a second item from a group of n items, then the total number of the two item choices is m times n. So let's look at the tree diagram and look how that works. So it says a representation of all possible choices. This T diagram shows that there are 2 times 3 equals 6 different outfits from 2 pairs of jeans and 3 shirts. So jean 1, see how we have 3 shirts. Jean 2 and the 3 shirts. So 2 times 3 is 6. All right, let's apply that to this next example. So it says the Greasy Spoon restaurant offers 6 appetizers and 14 main courses. In how many ways can a person order a 2-course meal? So choosing 1 from 6 appetizers and 1 of 14 main courses, the total number of the 2-course meals is 6 times 14, which we get 84 different 2-course meals. So then the next one, it says the fundamental counting principle with more than 2 groups of items is the number of ways in which a series of successive things can occur is found by multiplying the number of ways in which each thing can occur. Is found by multiplying the number of ways in which each thing can occur. So the number of possible outfits from 2 pairs of jeans, 3 t-shirts, and 2 pair of sneakers are 2 times 3 times 12. So all you're really seeing is anytime you have numbers as your representation of items, you're just going to multiply them all together. So we have the 2 jeans, the 3 shirts, and then the 2 pair of sneakers. And then those get applied for all the outfits. So 2 times 3 times 2 is going to be 12. All right, let's apply that to an example. So next semester, you're planning to take 3 courses: math, English, and humanities. There are 8 sections of math, 5 of English, and 4 of humanities that you find suitable. Assuming no scheduling conflicts, how many different 3-course schedules are possible? So remember, you look at each of your choices and you're going to multiply them all together. So you would do 8 times 5 times 4, and then if you put that in your calculator, you would get 160. Or if you multiplied it all out, you get 160 choices. So there are 160 different 3-course schedules you could have. So that's a lot to think about when you have that many choices. All right, let's look at another one. So it says you are taking a multiple choice test that has 10 questions. Each of the questions has 4 answer choices with 1 correct answer per question. So if you select one of the 4 choices for each question and leaving nothing blank, how many ways can you answer the questions? So we're going to be multiplying 4 10 times. So what that means is you're going to 4 for question 1, times 4 for question 2, times 4 for question 3. And see how it has that dot, dot, dot? So question 4, question 5, question 6, 7, question 8, question 9, question 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for each question, you're going to have that multiplication. So that's also equivalent to 4 to the 10th power. So if you put that in your calculator, you get 1,048,576 ways you could answer the questions. That's a lot. Okay? All right. Let's look at the next example. Telephone numbers. So telephone numbers in the United States begin with 3-digit area codes, followed by 7-digit local telephone numbers. Area codes and local telephone numbers cannot begin with a 0 or 1. How many different telephone numbers are possible? So this situation involves making choices with 10 groups of items. Here are the choices for each of the 10 groups of items. So you have 8 times 10 times 10, because remember we can't include 0 or 1 for our first numbers. So that's 8 options, but we can choose them for the second two numbers. So 10 number choices and 10 number choices. Then your next set of numbers is 3. So same deal. Can't be a 0 or a 1. So 8 and then 10, 10, because it can be any of the 10 numbers. And then the last 4 numbers, it doesn't matter which number it can be. So you have 10 choices, 10 choices, 10 choices, 10 choices. So we're going to multiply all those different choices all together. So 8 times 10 times 10 times 8 times 10 times 10 times 10 times 10 times 10 times 10. I think I got all the correct numbers of tens in there. So if you multiply that together in your calculator, you get 6,400,000,000 different telephone numbers. So that's a lot. So if you think we're going to maybe run out of numbers, it could be possible if we get up into the billions for our U.S. population. But not everybody has a phone number. Like little kids, if you think about it, don't have telephone numbers until they're older, and then they recycle the old telephone numbers when you switch plans or whatever. So kind of like they're never run out of those telephone numbers. So at least for the United States, that is. All right. If you have any questions, please let me know. Otherwise, work on your assignment. That is it for 7.1.